Can you see my screen?
Yeah.
Okay, perfect. So SQL, structured query languages. So SQL is one of the languages that are used for manipulating and extracting as well as organizing data in databases. So we first look at the definition of a database. So a database is a collection of related information. So this information can be organized and structured in a way that is understandable to the user. And most of the time, databases are usually stored and they are retrieved electronically. And so we can see we have there are different ways we can store data. We can use PowerPoint slides. We can store data in your mind, in a comment section. But for the databases that we look at, they're electronic. So we will store the data in a specific format. So there are different types of databases. There are different types of databases. That's relational and non-relational databases. I'll tell you about that. So you can skip. So to work with databases, we usually use database management system. A database management system is a system which helps us to create as well as maintain a database. So it depends whether are you trying to come up with a new database that has not existed before, or are you trying to maintain an already existing one, or are you trying to manipulate data that exists in an existing? So that's where database management systems come in. So database management systems make it easier to manage large amounts of data. Sometimes you can find an organization has lots of data, and this data it's best stored in databases instead of, you remember the earlier ways of storing data. People could use maybe Excel sheets. People could use, they could write it down on paper. So the database management system, that's where they come in. They help us now to manage this data. Instead of having this data in Excel sheets or in paper, on paper, it now gets easier to retrieve and access this data. Database management systems also provide security features. You can encrypt data the way you want, and they're easy to backup, and uh, just like Excel sheets, possible to import as well as export data. It depends on whether you want to do it in whichever format you want. Most times you can retrieve the data as Excel format or whichever format. The other way that a DBMS system helps us is currency, and it also helps us interact with software applications. So most of the software applications that you have on your phone, in the backend, have uh, they have a database. That's where they store the data, as well as not only mobile application, even computer application. Just literally every application needs a place where it can store data. So database management systems help us interact with software applications. So here we have an example of a Facebook database diagram. So we have Facebook, which is an application. So let's assume Facebook is an application in your phone, and we have a database right here. So what happens is, for example, if let's say you want to post something, you want to post an image. What will happen is usually an order of how these things happen. There's usually create, you read, update, and then you leave the information. So when you want to post something from Facebook, you post it to the database, and from the database, let's say for your friend to see the post that you posted, they have to query the database. For example, for the posts that you usually see on either Facebook or Instagram or anywhere, that data is usually stored in a backend, and the backend is the database. So from the database, the data is retrieved from the backend and brought forward back to the application that you're currently using. So that's an example using Facebook. You can think of other examples such as what other application? Literally all applications have a database at the backside, and most times we as users usually just see the front, and that's the app that you're interacting with, and we don't know where the data is going to. So this data is usually stored in a database. So once you ask the database for data, you now get back the data in the application that you're currently using. So there are four main operations that are carried out in a database. So we have create. So create is the creation of tables. We have read. Read is reading what's inside a table inside a database. We have update. Update is, for example, if I change my name from Pascal Chalo to maybe Pascal Strasmo, for that change to happen, we must update the database. So that's what update does. And if I want to delete a record from the database, we use the delete operation. So those are the four main operations that are carried out on a database. So that creating a table, reading is reading entries or rows in a database. Update is changing up information inside the database, and deleting is doing away with information that is inside the database. I hope I'm not going so fast. If I'm going fast, let me know. Okay, so there are two main types of databases. First one is relational databases. The second one is non-relational. Just from the name, a relational database involves or includes coming up with tables that organize data in such a way that the data in this, let's assume you have a table for school and a table for students. So these two tables have to relate just from the name, relational databases. So they usually relate. The tables have columns and rows, and each table has a unique identifier. So for example, if we have two tables, let's assume you have a table student, the unique identifier is literally just from the name, uniquely identifies each student. And for school, we could have maybe something like a school ID. So assume we have 1,000 schools in Kenya, and you want to come up with a table that shows a list of all the schools. You'll give each school a unique identifier. That's usually, it's known as a primary key, which we will look at as we move on. So each table usually has a unique identifier, same way as for a student table. So a student table is even easier to understand because we've all gone through school, and you find that everyone has a unique identifier, which is a student admission number. So using such information, that's the unique identifier, the tables in a relational database are now able to it's able to make out some relation between the two tables. Well, on the other hand, in relational database, they do not store data in rows and columns. The data is also not relational, so you can store the data in key value stores, in documents, in graphs, in flexible tables. Even Word document can be referred to as non-relational databases because the data there does not relate, unlike relational databases, which is made up of tables, and these tables are made up of columns and rows. So that's for the two types of databases, and for this class, we'll focus on the relational databases, the one that includes the tables and also the columns and the rows. So we can start off with the relational databases, just the way we discussed. It's made up of a table. So this tool that is the table. It has rows. This table has 1, 2, 3, 4. It has 4 rows and 3 columns. So it's made up of rows and columns. So relational database management system. Remember, first we had looked at database management system at large, but now we are focusing on relational database management systems, which still do the same thing. They create and maintain data inside relational databases. And we have a number of examples for relational databases. The most common database is MySQL. That's our database management system. We have MySQL, we have Oracle, we also have MariaDB. And now, we now come to the structured query language, which is now the language. For example, if you've heard of people who develop software or mobile applications, they usually have this one. Someone can have one language that they use to develop the application. Someone else might have a different language. So for us to be able to manipulate a database or create and do different things with the database, that's where we use the structured query language, which is SQL. So SQL is just a language that is used to work around databases, trying to manipulate the data, trying to create, trying to read, update, and delete. So SQL is used to perform the CRUD operations. That's create, read, update, and delete. Remember, CRUD, these are the 4 main operations: create, read, update, delete. So SQL can be used now to define the structure, that's the schemas. So when we talk about schemas, the schema is just the general structure of this table. For example, for a table, the structure of this table is we have 3 columns. It has the ID, it has a name, and it has a course. And we can also define the tables. And we can also define the relationship between the tables. So for the relationships, we will look at the unique identifiers, how one student will be linked to one school, or maybe one teacher can be linked to a school, maybe. So that's how the SQL works. So that's the main purpose of the structured query language. Okay, so we can look at this example where we have a student table. So we can see the student table has 3 main columns. That's the student ID, we have the name, course. So primary key is a column. So a column can also be called an attribute. So a primary key is the column or the attribute which uniquely identifies that result. So this student who's called Pioma has a student ID of 100. This student called Pika has a student ID of 101. And in no case will you find 2 students sharing the same ID, which is the primary key. So when you were a student, you remember you had your student admission number. So that number uniquely identified you. which is the same case here where we have the student ID. Sometimes you can find someone who has the same exact name as yours. For example, you can find someone called Pascal Chalo around here. But what will uniquely identify each one of us is the primary key, which is the student admission number. So you can see for the first and the third record, that's 100, ID number 100 and ID number 102. The names are the same, but the students are different because they have two different student IDs. So you can even see they share the same course. So the primary key is the attribute which uniquely identifies every row inside the table. So we have the types of primary keys. So we have surrogate keys. So surrogate keys are mostly surrogate keys are incremental in nature, in the sense that they do not have any business meaning to that specific thing. For example, if we had for example, this first column, the student ID, we can assume this is a surrogate key, in the sense that you can see the incrementing from 100 to 101, 102. So that's a surrogate key. While on the other hand, natural keys, you find that natural keys are usually related to the information inside the table. So if we had a student ID column, instead of having incremental numbers like 100, 101, we can find that. Okay, let me think of an example. Yeah, so the student ID. So let's assume the course is data analytics, and the abbreviation for the data analytics course is DA. For cybersecurity is CS. So for natural keys, remember the natural keys are related to the information inside the table. So for the student ID, if this was a natural key, student ID will be something like DA 100. So then the natural key will be something like CS, maybe CS 100. You find that natural keys usually related to the information inside the database. That's inside. And like surrogate key. Surrogate keys are usually just incremental in nature, and they try to just give a general key on different items inside the table. So that's on the two types of primary surrogate and the natural keys. So we can look at primary keys, for example of a primary key, and how they can be used to link to tables. So remember, we are looking at relational databases. And relational databases are the ones where they comprise of one or more tables, and these tables are very linked in a way. So in this example that we're having over here, we have two tables. That's the student table, and we have the company table. So we can see we have this student ID, we have the student's name, course, and the company. Maybe this is probably a company where the student is working. And inside the company, we have the company, the name, the department, and then the company. So so remember that this one right here is the primary key for this table, this company table. When this one, the student ID over here, is the primary key for the student table. So for us to link the student table and the company table, we create a foreign key. So a foreign key references the table that we want to combine with the main table. So for example, we have the student table and we have the company table. So let's assume the student table is our main table. On the rightmost column, we have the company column. which is showing us the primary keys for the different companies we have here. So we can see, without looking at the company table, for student ID number 1, whose name is Chioma and does data analytics, is in a company whose primary key value is 101. So when we come down to the company table and try to look at a company with the primary key 101, you'll find that 101 is this company called TechQuest, which is also the same case for this other company with the number 100. You can see this other one with 100, company with primary key of 100 is Prestige. So that's how you link one or more tables inside a database using the relational databases. So it just same case for a student table. Same case for student table. So let's assume for the student table, you have the student ID. Let me just make it. Just a minute. Okay, I was trying to find a drawing tool, but let me just explain the second example to you. So let's assume we have a student table and we also have a school table. So in the student table, we have, let's say we have the student ID, that's your student admission number. We have your student's name, and we also have your class, what class you're in. On this other side, we have a school table. In the school table, remember, we must identify each school uniquely. That's we must give each table must have primary key. So for the school table, just like in the student table where we have the student ID as the primary key, in the school table we have the school ID as the primary key. We will also have the school name and maybe where the school is located. Is it in Kenya? Is it in Uganda? So now, remember we have the student table. So for us to know which school a student is in, instead of having to add all this, remember we have to, I wish there's a way to annotate. I'm not so familiar with these. Okay. I'll just post it in the chat. So for the student table, we have student ID, we have the student's name, we have the student's class. So that's for our first table, which is the student's table. And for our school table, we have the school ID, have the school name, maybe the school location. It shows the location of the school. So for us to know where the school a student is in, we don't have to see. We could possibly create a table that shows the student ID, the student's name, the student class, the school name, and the school location. But instead of doing that, we can break this one whole table into two. That's the student table and the school table. So now, for us to know which school a student is in, what we do is just add the primary key, the school ID primary key from the school table, which will be a foreign key in our students table. So that's how our, let me just share this. So when you look at the third message of send, that's the student table. We have the student ID, we have the student name, we have the student class, and then we have the school ID. So using just the student table, we can reference back to the school table. You can see that the school table and the student table have one column in common. That's the school ID. So it's possible to know the school where a student is in just based on the primary key. So that's how primary keys basically work. I hope that's clear. Okay, so database queries. So when we want to communicate with the database, when we want to maybe create or read or update or delete, we use queries. So queries usually make requests to the database management system. So just using our example for the student in the school, if you want to get a list of all the students, we send a query to the database, and once the database understands what you're trying to ask from it, it then it gives us back the information that we want based on the query that we've given the database. So database queries can be simple, they can be complex. So it depends with how many tables you have. So remember, the more tables you have, the higher the chances of having complex queries. And complex queries sometimes can be hard to navigate, especially because of uh, things like the query having to read through so many tables for it to give back the information that you want. So as the database structure becomes more and more complex, it becomes more difficult to get specific pieces of the information you want, which is what I was just saying, the complexity. So the more tables we have, the more complex your queries will be. So it's always best to try to have your queries as simple as possible. And one simple example of query, when you just do a Google search, that's a query. So when you try to Strathmore University, that's a query. You're asking Google to give you information about Strathmore University, which is just the same case, but that is not structured. That's not a structured query language. That's not SQL. That's plain text. But in the backend, you find that it converts that to maybe the structured query language, and it goes to the database and tries to find information about Strathmore University, which is just the same case as uh, the database queries that we will look at in a few. Instead of having to convert the text that you've written to maybe the SQL language, for our queries, the queries will just be directly manipulating the data and maybe doing the CRUD operations directly. So that is what a database query is. So queries are used to make requests to the database management system for specific information. So if you want to maybe get a list of the schools in Kenya, so using queries, you can even filter out. So you can filter out the schools that are found in Kenya, where the schools are found in Uganda. You can filter out the students in a specific class. So that's how database queries operate. So SQL is made up of four different languages. It's a data query language, a data definition language, data control, and data manipulation. So our class will mainly focus on the data query language. So we want to see how the data how we can make requests to the database and retrieve information based on the specific needs that we have. So these are the four main types of languages inside SQL, and we'll focus on the data query language. That's the first one. So we can look at an example of a query. So queries usually have keywords, and then so some keywords that are used for querying include select. So the select keyword is used when you want to make a selection, and then the from keyword, as you can see in the example that I'm displaying on the screen. So the from specifies from which specific table do you want to retrieve this information from, and when you want to do, maybe when you want to retrieve information from more than one table, you can move on to the advanced queries whereby you use uh, joins. So joins are used to connect more than one table. That's if you want to retrieve information from more than one table. And then we have where. So the where clause is used to specify, for example, if we want to retrieve schools where uh, the school location is Kenya, that's how the where clause works. It's just used to get more specific with your query. So for example, we have this query over here. So we are trying to select the name of the employee and the age of the employee from. So from employee, so employee over here is the table. That's the name of the table. And then where, the where clause, we are now trying to narrow down our query. We're only giving us only the employee, the name and the age of the employee with a salary of more than 30,000 Kenyan shillings. So this is an example of a query whereby we are trying to read information from a database. So we can move on to how we will set up our database management system. So we'll be using MySQL Workbench. And let me just share this link with you. So I'm sharing the link on the chat. So use that link to download the MySQL Workbench. So please download the second option, call it a large file.
Hello, Mr.
Yes.
Kello. Yeah,
Yes, Abdullah.
which one do we install? The second one, 285.3 million.
Yes.
Okay,
Yes. Yeah.
it's showing 32 bits. Oh, that's okay.
Yes, that's okay.
Okay.
So try to follow the steps that are listed on the PowerPoint. Just your part, let me know.
Umeona Elif? Ama wewe unakuanga next. Sawa.
So have you been able to download and also add it to the environment variable? So make sure you download Workbench as well as MySQL. Anyone facing a problem with setting up? Okay, We hope everyone has been able to install MySQL as well as Workbench. So I hope you remember your passwords as well as the username, which is most times by default is root. So for us to test whether we've been able to install MySQL, we can open our terminal. That's the command prompt. So once you're on your command prompt, let's type this first command here, starting from my SQL-H localhost. So -H is used to specify the localhost, and then -P specifies the port, and then -U is the username, and then -P is the password. So notice there's a capital P and there's a small p. So the capital P is the port number, small p is the password. My SQL uses port number 3306. So we can try run this first line, MySQL-H localhost-P. We can try running it on our command prompt. So that prompts you for the password. So give it the password that you had initially when making the installation. So we can move on to see how we can create a table. So before creating a table, we first have to create a database. So the database is the structure that includes all these other tables. So we could have maybe, please mute your microphone. Okay, yeah, so we first create a database and then we create a table. So the database is the structure where the tables are found. So we can start up our workbench after you've installed. Just share my screen.
Hello, excuse me. I'm not sure I'm getting your audio. Kindly.
Oh, sorry about that. Anyone else who's not hearing me clearly? Oh, I'm sorry, I was on mute. Hello, Sarah, Sammy, and Faith, where were you left behind? Should I repeat how to come up with the table? Am I audible?
Yes, you are. Currently now you're audible. Thank you.
Okay, so where were you left behind? Should I repeat on how to create a table?
Yes, kindly. I'll appreciate on the creating of tables.
Okay, so the syntax of creating a table, the way we've seen over here, the first query is create table. It's quite straightforward. You just say create table, and then you specify the name of the table that you want to create. So for our example right here, we create a table that's called SpecQuest. And inside, when you're creating a table, you specify the columns that you want to be in your table. Remember, a table is made up of rows and columns. So when you're creating a table, you just specify the columns that will be inside your table. So for example here, we have the staff ID, we have the name, we have the job role, and the salary of the different staff members. And remember, when you're defining the table or when you're creating a table, you must specify the data types. Remember, we've looked at the data type. You have the integer, we have the variable character, we have the decimal, we have the blob. So for example, staff ID, a staff ID is most times usually a number. So for you to know which data types to use, you must first maybe take a look at your data. Do the staff IDs have numbers or do they just have text, and so on and so forth? So for example, the staff ID here is an integer. So int is an integer, and the primary key, you're specifying that the staff ID will be the unique identifier for this table. So for the TechQuest table, the staff ID will be a primary key. So the staff ID will uniquely identify every employee in our table. And then we have the name. So the name is a variable, we give it a data type of a variable character. So the variable for the variable character, you can adjust the length. So that's the number of characters for that specific column. So for example, we can we can assume that the longest name in our table will be 30 characters long. So we give it a length of 30. And then for the job role, we have a variable character also, because job role, like maybe a data analyst, is usually just a combination of letters. And those are just characters. Then the salary, which will be a decimal, it can also be an integer. Just depends. Are you working with cents? Are you working with a full number? So the salary, for this case, we define it with the decimal. I hope that's clear. I wanted to show you how this will look like in the database after creating our database. Okay, let me move on to let me move on to my workbench. Okay, so since we are working with employee data, we can start by creating a database. We can maybe call it. So once that's done, I can refresh over here. We can see right here, I created a database called employee. So inside a database, we find tables. And we've seen the syntax of creating a table is, so we create table, and our table was named TechQuest. And then we had the staff ID, which was an integer. And this will be our primary key. Remember, it's the unique identifier. And then we have, let me check. We have the name, which is a variable character. Okay. Have the name, that's the name of the employee, and that will be a variable character. And then we can specify the length of the name. And then the next attribute will be the job role. And just creating the same table that in our example. We can also give this a 30. And then for the salary, and maybe give it an integer. So for the integers are just two numbers. And yeah, and then you can give it semicolon. So when we run this query, it will create a table called StackQuest. So when we look at when we refresh this, when we refresh our database, remember employees our database. Let me just pull this down a bit. When we look at our tables, you'll notice that we've created a table over here called StackQuest. Right here. So that's the syntax of creating a table. If we want to create another table, we can do the same. We can create a table maybe called employee location. Then inside the employee location, we can give it a location ID. So that's the ways that's like, now we can give it an integer, and then the location name, we give it a variable character, and maybe we assume that the length of the name will be somewhere around 20 characters. And then from there, we can maybe whatever, okay, we can see where the country, that location, which country is it in. So it will be also a variable character, and also give it, we can also give it a length of 20. So when we execute this and refresh this database, you'll notice that we have created a new table, this right here, called employee location. And when we can see the columns, we can see the location ID, the location name, and the location country, as well as the TechQuest. We can also see the columns right here, the ones that we created. So we can go back to presentation. I hope that's clear. Any questions on how to create a database and a table?
No, excuse. Hello. Hello.
Hello. I'm so sorry. I've been muted all that while.
No worries. I have a question.
Yes.
What do you intend to achieve by introducing that word? I'm not sure whether I'm pronouncing it correctly, but Vec or Vat or whatever you've written there.
Hmm. Which one?
While creating a table, you've written something like
Okay.
after writing
This one right here?
yes, that one.
Okay, so
Yes, that one.
So when you're creating a table, you must define the data types. That is the staff ID, the data type. That's the data that will be inserted into the staff ID will just be integers. So if you insert letters, staff ID will refuse. It will throw an error since you defined it to take in an integer. For the name, which is the variable character, that's the varchar. In full, varchar is variable character. So what a variable character does, it takes in both numbers and letters. So if you have a column that will take in maybe letters, for example, a name of a person, or maybe you want to, for example, something like a PO box. A PO box is made up of letters and numbers. So if you want to store information on the PO box, you use a variable character. And then for the 30, the 30 specifies the length of that, the length of each entry into that. That's longer than 30, that's longer than 30 characters, it will throw an error because it's expecting that column to have a maximum of 30 characters. Do you understand the varchar, the variable character?
Okay, yeah. So for the name, while you're writing that, it means we'll have a maximum of 30 rows, or do you mean the characters in the name?
Characters in the name. For example, the name John. The name John has 4 characters. So if we add the name John inside the name column, it will be accepted because it's less than 30 characters. But if we inserted a name that's more than 30 characters, which is quite impossible, it will throw an error because it's longer than the 30 characters that it expects. So before you come up with this data types, you first have to understand what type of data you'll be ingesting into your table.
Okay. And so in this case, yes,
Yeah.
but in this case, you've said the variable character takes in numbers or letters. So in this case, in the name column, will it know that it's supposed to be using letters instead of numbers, or it can use both at the same time?
Exactly. It can use both. It can use either letters, it can use numbers, or it can use both at the same time. That's why I gave the example of if you wanted to maybe add the address of a person, most times you find someone's address is made up of both numbers and letters. That's the 0, 1, 2, 3, and we can find letters such as A to Z. So that's how variable character works. It can take in numbers, letters, as well as a combination of both.
Okay, thank you.
Okay, you're welcome. Okay, so when I was on mute, I was trying to show how to insert data into a table. We can do this as one example. So the syntax is of inserting data into a table is insert into, and then you specify the name of the table name, and then you then give it the column that it insert the data into, and then the keyword values. So inside the values is where now you specify In the staff ID, I want the staff ID to maybe be 3. Okay, let me just. So for the staff ID, we can do 3. For the name, and let's do now combination of both, because we've defined the name to be a variable character. Let's see how this will behave, because it's a combination of both letters and numbers. And John works in, maybe John is a data analyst and is making a salary of that amount. So when we run this query, once we run that query and do a select, also remember select all is for selecting all the records in a table. Once you do the select all and we run this, you can see that John 124 has appeared inside here. Because we defined the name column to be a variable character. It can pick both, it can store both numbers and letters. So you can try insert maybe a fourth staff ID or and a different name, a different job role, and maybe a different salary. We can try John, Diana. Does Diana do? Diana is a lecturer. And she earns that same amount. So when we run this query, it inserts data into our TechQuest table. So you see, before we inserted data into this table, we had only 3 entries. When we do a select all, see the most recent updates, you can see a staff ID of 98 was added, a name Diana was given, the lecturer role, and the salary of that amount. So this is the syntax of inserting data into a table inside a database. So we can look at how we can drop a column. So to drop a column, remember we are trying to change how the database looks like. So we alter the table, that's changing. These commands are very English-like. So it's not so hard to remember a command. If you want to change something in the table, remember you do an alter table command. So want to alter table. The name of our table is TechQuest, and we want to drop column. And what column do you want to drop? You can choose the salary column. So just as you guessed, dropping is deleting a column. Once we run this query and we do a select all, remember when you look at this table right here, it has 4 columns. But remember we've dropped the salary column. When we run this, you can see the salary column has been dropped. So when you want to add a column, you do the opposite. Instead of dropping, you just do an add column. Remember to specify the data type. Once you run this command will add a column to our table, which is the TechQuest table. So once we come back to our table over here, When we do a select all, remember we had dropped the salary column, so it's no longer there, but we've added the column back again. When we run this, you can notice that we've added a column salary. And the reason it has nulls, because there's no data inside it. Finally, okay, so that's it for creating tables and describing how the table looks like. And also, so the last command we are left with is the drop table for today. So drop table, just from the name, is for deleting the full table. But you hardly ever use the the drop table to and to drop the table, and the name of the table is TechQuest. So when we run this command, it will delete this whole table. We can do that. So when we come back here, when we run this query, it gives us an error. Table employee.techQuest doesn't exist. When we refresh over here, it's been deleted. As you can see, we only have one table over here, which is only the employee location table. We can also decide to delete the employee location table. See, it's been dropped off. So to delete a table, use a drop table command. So it drops the whole table. But it's one of the rarely used commands because it's hard finding yourself having to delete a whole table. So for this class, we've been able to get an intro into SQL, and also tried out a few commands. That's for creating the table, describing the table, inserting data into a table, selecting all. That's to just have a view of the whole table. We've also dropped our tables. We've also altered our tables. So for our alter table, we've dropped a column and we've as well added a column. We've also looked at the data types. So any questions before we call it a day? So the presentation will be shared with you. Okay, so unless there are any questions, I think we can call it a day. You can try create a table of your choice and try to populate the table that's inserting data. Just try out the different commands we've looked at today. So we meet again tomorrow same time to continue with the SQL class. So thanks for showing up. Okay, yes, Sami?
So I wanted to maybe, will you share the slides for the presentations kindly?
Yes, for sure.
Okay, sure, thank you.
You're welcome. Any other questions? Okay, so thank you so much for turning up. I'm sorry again for being a bit late. I'll see you guys tomorrow again. Have a nice evening.
You too.
Thank you.
Bye.